Good morning. I'm Bob Walde, as you see, Vice President of Technology for Surtreat. I'm one of the founders of the business and also the Chief Technical Officer. I go back with many years of history in industry, 35 years of working in major corporations, Gulf Oil, Air Products, Allegheny International. But in 1990, when corporate America came to an end, many of us realized that if we were going to have jobs, we were going to have to create them ourselves. And in the course of that, I became involved in two businesses, Shore Corporation, which, as you see, has the products Shore Best, and Surtreat. Shore is a manufacturer of specialty chemical formulations and makes all of the Surtreat products. Surtreat came into existence through a communication I had with Tony Fiasco about the need in Pittsburgh to restore old concrete structures to bring them into use for new applications. So he and I got together, and through my efforts in developing chemical formulations and knowledge of concrete chemistry, we put together a new formulation that would increase the strength of concrete, reduce porosity, and inhibit corrosion. And we took that out and applied it in an initial project in a parking garage in Columbus, Ohio. We've also developed a line of products using similar type of migratory corrosion inhibitors that can be used as an additive into paint to make them corrosion inhibiting, and particularly being able to paint over rusted steel. Now, what does the company do? What does Surtreat do? We're basically in the problem-solving business. Now, many other companies similar to ours have the concept of just selling products. They put things on the shelf, they put them in distributors' locations, but we don't do that. We took a different approach, and that would be that customers don't want to buy a product, they want to buy a solution to their concrete problems. The other thing we realized was that all of the problems that people see physically with concrete structures have an underlying chemical cause. For example, Portland cement concrete gains and loses all of its properties through chemical processes, such as alkali-silica reaction and pyrite reaction. And the most frequent cause of damage, reinforcing steel corrosion, is an electrochemical process. So we realized that we needed to use chemical technology to solve these underlying problems and then incorporate the chemical solutions with the classic chemical fixes, such as carbon fiber reinforcement, which we do with one of our associate companies, and even now the parent of Surtreat, Coordinated Systems Consulting, which is one of the leaders in the reinforcement of concrete using carbon fiber reinforced polymer mats. We developed a concept called total performance system. What do we mean by that? That means that we do other things than just deliver product. What we do, we first take a look at the problem, and as we see it normally in its physical form, cracks in the concrete falling off the surface, exposing rusty rebar. And we use this information to then dig deeper and determine what is the underlying cause of the damage. Is it alkali-silica reaction, rebar corrosion, freeze-thaw damage? And to verify the degree and type of problem, we do testing. We're one of the only company that actually does on-site testing as well as laboratory performance measurements. Just about all of our data on the performance of our products have been acquired on site where we're doing work on actual projects, measuring concrete strength, measuring the rate of corrosion on the reinforcing steel, and characterizing the problem, where we then can prescribe a specific solution for the underlying chemical cause of the problem. Go apply that chemical formulation to the concrete to correct the problem, and then follow up with measurements before and after application to verify that we have significantly reduced the impact of that problem, such that repair work that is now done will have a long life. What we're really doing here is extending the life of structures. Now here's just a few of the kinds of problems we solve and some of the products that we use. Rebar corrosion. You see we have several products that are corrosion inhibitors. TPS2 is a surface applied corrosion inhibitor that migrates in the ionic phase. It's a very powerful anodic inhibitor. TPS12 is a vapor phase migratory inhibitor. It's both anodic and cathodic. You're all familiar with a battery, the positive, negative pole. The positive pole, this is where electricity is coming from, or rebar steel corroding, losing electrons, is the anodic site. So TPS2 is a very powerful anodic inhibitor. TPS12 functions both in the anodic and cathodic states. And 15 is similar to 12, but is designed to be added to fresh concrete mix and be there as a latent corrosion inhibitor. TPS2 and 4 are concrete strength builders. We increase the compressive strength, the tensile yield strength, and the flexural strength. TPS2 is our multifunction product, which we have designed to do three things: rebar corrosion, concrete strength improvement, and porosity reduction. You need to reduce porosity to keep air, moisture, and corrosion-causing salts out of the concrete. TPS4 we use if we want to maximize strength building and porosity reduction, and all of those properties can be enhanced by the application of Repel WB, a very powerful, long-lasting water repellent. Concrete corrosion, when it's exposed to acids and other substances that react with the concrete, will cause damage, and TPS4 is then applied to inhibit those kinds of reactions. We've used TPS4 in places like battery recovery sites where they're spilling sulfuric acid on the floor, and we can inhibit the reaction of that acid with the concrete. Alkali silica reaction is a unique problem. This is where chemically active aggregate containing silicates reacts with the concrete cement alkalinity, causing a byproduct reaction that expands and causes cracking. We have two products, one TPS17 that's put into the concrete to pacify the reaction between the aggregate and the cement alkalinity, and TPS18, which is applied to the surface to increase the surface strength of the concrete to inhibit the formation of cracks. If you increase the tensile strength, it takes more of the reaction byproduct to put on pressure and cause cracking. Also, our paint plus VCI, which we call the VCI primer, can be put over corroded, rust-covered steel without having to have the very high cost of removing the rust to white steel, as is required by all other enhanced anti-corrosion coatings, particularly those containing zinc. Here we show a little bit about the Surtreat total performance process again, and we see a number of pictures here, but we see the identifying the physical form of the problem, diagnosing it through testing, designing a solution, having the products manufactured. Many times we can even modify formulations since we control the manufacturing operation through our very close ownership relationship with Shore Corporation, our product supplier. The blue drums we see here where Shore has delivered product in the form of 55-gallon drums to a site where it will be applied. And then we have pre and post application testing to verify performance and deliver healthy concrete with the life extended of the structure. We see two pictures here. We're working on an old railroad bridge. You can see rusty rebar. We're applying corrosion inhibitors. And then in the bottom lower left picture, see we've applied on one of our other products called Surcoat. It's a special coating that can be applied over the rusty rebar after the application of TPS2, which gives it a long-lasting cover. And it greatly reduces the very high cost of doing repairs back to the original surface conformity. Now, most of the benefit here, too, is one extending the life of the structure, which is a significant economic advantage. The more time you get out of a structure, the longer term that you are getting value from the original investment. But beyond that, what we do is we want to extend that life at minimal cost. And as you can see, what we do, we can apply the products initially, and many of them we can see over 30 years of continuous performance, such as parking garages that were treated 30 years ago, continue in service without having to have any maintenance work done during that period of time. The most important thing we're doing is inhibiting corrosion, which can be done during most, whether it's a new or an old structure. And you can see below, we have several projects here, and we show the alternative cost of solving the problem, but then what it costs to solve the problem using Surtreat. All right, parking was corrosion. We can see we 88%. Port Authority was a bridge foundation. We were able to salvage the foundation without having to remove it and rebuild it. Department of Energy, sealing concrete at nuclear sites to inhibit contamination. And Essex Waste, stabilizing the floor such that waste spills would not be damaging the concrete or causing contamination. Now, we work with many other organizations to verify and specify the use of our products, one of which is the International Concrete Research Institute, of which I have been a member for many years, and worked with them for over 10 years with members from many other companies, as you can see, and consulting firms, to develop a guide for the application of surface-applied migratory corrosion inhibitors. This guide has been published and is available, and we can make available to you. It specifies the use and application of 3 types of corrosion inhibitors: anodic, cathodic, and mixed or ambiotic. Surtreat makes and delivers all 3 types of these inhibitors. TPS2 is an anodic inhibitor. TPS12 is an ambiotic, or both anodic and cathodic, and Repel WB is a pure cathodic inhibitor. The significance of the Surtreat products, and particularly TPS2, is that it inhibits the anodic site, which is where all of the steel is being oxidized and converted into rust. And as we'll see later, rebar corrosion is not uniform, but it's taking place at anodic hotspots, such that most of the damage is occurring there. Another significant partner has been the U.S. Army Corps of Engineers and the Naval Facilities Engineering Command. Working together with these organizations, we conducted a project in Okinawa over 12 years ago, where we applied the Surtreat corrosion inhibiting and strength building and porosity reducing products to concrete at 2 military bases, one at a port in Naha and at concrete located at the Kadena Air Force Base. Most of these structures were built back in the 1950s during the Korean War. And with time, carbon dioxide in the air and salts from the environment had penetrated the concrete and caused corrosion. We treated the concrete and measured corrosion rates, strength, and porosity before application. And then over time, the Corps of Engineers and NAFAC sponsored other independent consulting companies to go back and continue to measure these properties. And what we found that over a 10-year period, the corrosion rates continue to be reduced by 80% from what it was when those corrosion rates were originally made prior to the first application. And we also determined that the strength of the concrete had been increased by about 1,000 psi, and the rate of water penetration had been taken to 0. And these properties continued to prevail and continued to today. And we've now been asked to come back and treat more concrete at the Kadena Air Force Base, which will be done soon as the coronavirus allows people to get back to work there. Here again, we just see a little more information about the nature of the corrosion problem. As you can see in the words here, new concrete has a high alkalinity. It's just high alkalinity that causes a stabilization of the surface of the reinforcing steel, inhibiting corrosion. But over time, as the alkalinity drops, which is measured by a means which we call pH, it's a way of measuring the degree of acidity and alkalinity. And what happens as carbon dioxide in the air penetrates the concrete, it reduces the pH, and chlorides and other acids penetrate, putting the rebar surface into a corrosion active state. And what happens, as you can see, the rust forms, and rust occupies about 6 times the volume of steel because it's being added oxygen to the steel. It expands and puts pressure on the surrounding concrete, causing delamination and spalling. And when the concrete then spalls away, we find damage to the concrete, which is usually the first reason that owners of structures call us to do anything. Now, if you're going to want to do something with rebar corrosion, you have to be able to measure the corrosion rate. And this can be done by several methods. One is the direct method, where you're actually measuring the flow of current from the anodic to the cathodic site. And there's an ASTM standard for that, G109. And this was the process that was used by NASA back in the early 1990s to originally work with Surtreat to vet our corrosion inhibitors. They made these measurements and determined that the active ingredients in TPS2 and 12 functioned to inhibit corrosion, and were very powerful corrosion inhibitors. And that TPS2 active ingredient was in fact an anodic inhibitor. Now, if the rebar is buried in the concrete, you cannot make connections to rebar in the anodic and the cathodic states in a macro cell condition. That means they're both in the same little block of concrete. But you have to measure the corrosion rate through indirect methods, which is polarization resistance. By measuring polarization resistance and putting that into a simple direct corrosion current measurement, where I equals corrosion current, V equals the over voltage, and PR the polarization resistance, we measure corrosion current. And we have an instrument called Galvapulse, which does that, and in a single measurement cycle. Half-cell potential has been historically the main method for measuring the potential of corrosion. What we're doing here is essentially measuring the voltage difference, or the differential between the anodic and the cathodic potentials. And there's an ASTM method for that, ASTM C876. This just measures the potential for having corrosion, but it doesn't actually measure the corrosion rate. Here we see the Galvapulse instrument in action. What we do, we connect it to a piece of rebar, as we can see the rusty rebar with the connection. Then we have a sensing probe, which sends an electrical impulse into the rebar and measures the polarization resistance as it polarizes and depolarizes due to the electric current. The polarization resistance is automatically measured in the software embedded in the handheld device, which then runs calculations to show the corrosion current, the half-cell potential, and the resistance of the concrete, which is important because as the concrete resistance goes up, corrosion current is less likely to flow and have corrosion occur. We use this device to make all of our before and after corrosion rate measurements. Here's a little example. This is probably one of the most important things we're going to talk about today, how we actually go out and make application of our corrosion inhibitors in an actual structure, in this case, decks of a parking garage. And what we did, before we did anything, we went and mapped out 26 points out over the rebar mat on the deck of the garage. And we made corrosion rate measurements there. We then applied our two corrosion inhibitors. We applied TPS-12, the vapor phase inhibitor, rate of 150 square feet per gallon, which is the standard method we use for measuring application rates. We next applied TPS-2 at 200 square feet per gallon. We then waited 6.5 months and went back and redid these measurements at the 26 points using the Galvapulse. And what we're able to do is we take the corrosion rate, which is measured in microamps per square centimeter, and 1 microamp per square centimeter equals 11.6 micrometers of rebar steel lost per year, which is the real corrosion rate. And we can see these rates imposed where we're measuring the before, which is in red, and the after treatment in blue. What this shows two very important things. One, that the corrosion rate is not uniform, but we can see where we have these corrosion hotspots. in spots starting at 18 on up through 26, while 1 through 15, we're staying pretty much below 50 micrometers per year. But then we have hot spots going all the way up to 400 micrometers per year. And it's this area where we had the maximum loss of steel and damage. The important thing to see here is that through the application of TPS2, we've quenched these corrosion hotspots. The other classic methods that are used for inhibiting corrosion, which uses cathodic protection, only drops the average rate of corrosion, but it doesn't kill off the corrosion hotspots. It just reduces them, but not to the extent that TPS2 can. But you can see how by inhibiting the corrosion, we've dropped the corrosion rate down. And what's the significance of this now with life extension, which is the main thing we're really selling here to Surtreat? We're selling the extension of life of concrete structures at minimum cost today and into the future. That's what we sell. Now, in measuring how we extend life, we have to make certain assumptions for calculations. In this case, we assume that the rebar at 0 corrosion rate was 20 millimeters, and that once we had lost 20% of the steel in certain sections or on the rebar, which would be 4 millimeters of steel, that we are in a critical structural point. We can design an equation where we can measure the time it takes to reach that point of the loss of 4 millimeters of steel at a given corrosion rate. So we see T equals the diameter loss divided by, and this is a correction factor, 2 times 10 to the minus 3. What we're doing is we're correcting for corrosion, for loss of steel as under corrosion rate in micrometers to millimeters, and from radius to diameter. And where R is the corrosion rate at given time, and K is a factor that takes into account the fact that corrosion rate is not even, and it takes into account for those corrosion hotspots in our calculations. So here we find that the original corrosion rate was 100 micrometers per year, and after treatment, the average rate dropped to 28, but the 5 highest corrosion rate points averaged at around 250 micrometers per year, such that the hot spots were corroding at 5.5 times the rate of the average. So that gives us a K factor of 2.5. So now we see our calculation here. We have T equals 4 millimeters of steel lost, times 100 micrometers per year, times the K factor of 2.5. And this shows that within 8 years, we would see damage. And this is typically what's going on in parking garages. Every 10 years, they come back, do repair work, fix these spots where the hot spots were. 10 years later, guess what? They're back again, rebuilding the garage in 5 to 10 square foot sections every 10 years. After application, we've killed the hot spots. We've reduced the average rate, so it's going to be 72 years before any possible maintenance work might be done. So we've significantly extended the life of the garage, maybe even beyond its useful life. As many times old garages are torn down just to make room, like it was for the garage in Columbus, Ohio, for more valuable use of the space. Here we see some pictures. Now we're getting into some specifics about parking garages. Here we see a picture of the work we did on the parking garage in Columbus, Ohio. You see the picture below, we're applying Surtreat. In this case, on concrete that was in very serious physical conditions, where it had been scarified to remove old asphalt coating. It was crumbling. Here we're applying TPS4 at a very high concentration, stabilizing this concrete surface. Here we are in Memphis, Tennessee, where we had concrete that was suffering damage. We're up on the roof. Here we treated the roof, took up the old coatings. There was another contractor put down a hot rubber membrane on the roof, and then another contractor replaced the concrete, putting this garage back into service. Here we see this is a very interesting project, one in Pittsburgh, a new construction, West Penn Hospital parking. It was built back in 1990, and through someone who was on their board, he said, look, we got this new garage and we have Surtreat. I recommend that you have Surtreat treat the garage and we'll never have to do any repair work on it. Well, he was able to get them to agree to that, made the funds available, we treated it, and now, over 30 years later, that garage in Pittsburgh, we go back and inspect it, there's not one area of that deck that has ever had to be repaired. And it's been exposed to the Pittsburgh environment where every winter cars are dragging in de-icing salts, wanting to put that concrete into a corrosion active state. Here we are, Lancaster Parking Authority, project we did years ago on the ramps. Stabilized the ramps, treated them, repaired them, brought them back into surface. Since then, we've done other parking garages in this same area in both Columbus, Ohio, Lancaster, and Harrisburg. We've done well over 100 parking garage projects. Here we are at Harrisburg. Here's a significant one here. We had problems with concrete, and we have a little video here that we can show where we're going through the garage, treating it. We can see we have damage to the ceilings and whatnot. But here we have another picture of this garage. And what happened here, we had damage to the beam ends. And you can see here damage to the center parts of the beam. Concrete was lost. Well, the engineer for Harrisburg Parking Authority was alarmed by this problem. And he said, look, you've got to reinforce and fix these beam ends because the major cause of damage to parking structures is shear failure from the deck. So we came in and we inhibited the corrosion, repaired the concrete, brought it back to original conformation, and then reinforced it with carbon fiber polymer impregnated mats. This work was done by our parent company, Coordinated Systems Consulting. And once that was done, the engineer said, yes, we can put this garage back into service. We can now park cars up on that top deck. And we then went on and along the beams here, he said, well, no, you don't have to do that. Just inhibit the corrosion. And there we treated the surface with Surcoat to prevent damage and bring it back to original appearance. Here we are, Miller Parking. Now what you can see here, see this top deck, look at all this repair that was done here. The whole deck, I mean, they had been, almost 50% of this deck has been replaced. We came in, treated that whole deck with Surtreat to the best of our knowledge, and this was done probably a good 15 to 20 years ago. They've not had to go back and do any further repair work. Torpedo Factory, this is one of our most recent projects. Here, they had brought in a consultant. The consultant came in and said, "Oh my goodness, we did a chain drag. You got delamination here and there." Talked him into doing all these repairs, which, and then he said, "Well, you got this coating here. It's probably the coating's no good. You got to take it up and replace it." Well, that was really going to cost money. Well, one of the members of the board who owned the top deck of this garage, a condominium called the Top Torpedo Factory Condominiums, got in touch with Surtreat and said, "Look, can you guys come here, take a look at this, tell me what's going on?" So I went there. I fortunately live here in Virginia, so I could get to the garage very quickly. And as soon as I saw it, and I went around and tested, I said, all these repairs were unnecessary. What's happening when they did the chain drag? They're just measuring the difference in the thickness of this coating. There was no corrosion taking place. This coating, and we did porosity measurements using our method, a Rowland tube. It had zero porosity. It was a very strong, non-porous coating. We went and we made corrosion rate measurements. There was no rebar corrosion. We measured the chlorides. There was no chlorides. They'd spent all this money on these repairs. But one of the things I did find that when I was making some applications of Repel and TPS2, I saw that this coating was riddled with micro shrinkage cracks. And I told them, I said, look, if anything's ever going to happen here, water and salt are going to get through these shrinkage cracks. What I recommend you do, and the surface was very dirty, we'll come in, we'll clean the surface, give you a nice clean surface, and then apply our migratory, long-lasting water repellent, Repel WB. And I determined that the application rate would be 200 square feet per gallon. We did. We came back and using the CSC application team, you can see here we have 2 drums on a little cart. Then here's with a pump and a spray bar. We went and treated the decks. You can see here's a deck treated after application. We're still waiting for it to dry. But we sealed all those cracks and we have it now back in service. Well, here we are getting to the end. Here you can see some actual work being done, applying Surtreat with spray bars, reinforcing things with carbon fiber. Here we are working in Korea. We've done a lot of work in Korea. Here they are getting ready to make measurements. Here's our water penetration cell where we can put it up here and actually measure the water penetration rate under hydrostatic pressure. What we've found is that water repellents alone don't keep water out under pressure. Only sealing the porosity can do that. With TPS2, so many times we apply TPS2 on building exteriors, then followed by Repel. Here they're getting ready to set up for concrete strength measurement, measuring the pullout, the force it takes to pull a plug of concrete out from the surface. Here we can see a deck treated. So here we are. We can do turnkey projects, or we can deliver technical consulting and product to anybody's contractor, apply to the surface, solve the chemical problems, and deliver the Surtreat solution, extending the life of people's structure, going on into the future, saving money. And now I thank you, and we now can have discussion and answer questions.